Hello, Year 11. We're going to go ahead and look at 7C, which is the binomial theorem. And this is kind of bringing together everything we've been talking about over the last few days. So just going back to realizing that Pascal's triangle will give you your coefficient for binomial expansion. Let's see what happens here if we can follow a pattern. So if we have two terms, binomial, raised to the 0 power, a plus b to the 0, anything to the 0 just gives us 1. If I take a plus b and I raise it to the first power, I'm going to wind up getting 1a, which of course we would just write a, plus 1b. So I'm purposefully writing these ones here so we can see what happens. And then a plus b to the second power, we're going to wind up getting 1a squared plus 2ab, and then plus 1b squared. So if we're already checking out our pattern here, we have 1 and 1. Both terms have a 1 as a coefficient, 1a plus 1b. 1, 2, 1. So 1a squared, 2ab plus 1b squared. And then we'll continue, so we should get 1. Now let's take a look at our exponents. My a starts with an exponent of 2, which happens to be the nth power as well, and then it drops to a power of 1, and now my a has completely disappeared. So my a is actually to the power of 0. Whereas my b term starts, well, we don't have a b to start, so that would be b to the 0 power, and then b to the first power, and now b goes to the second power, which is my nth term. I'm sorry, my n plus 1 term, or my power of n. So let's go ahead and see what happens when we raise a plus b to the third power. I get 1a starts to the third power. My b is actually to the 0, so I'm going to write that in on this step just so we can see what that looks like. My next term, so I've done this, should have a 3 as the coefficient. So 3. And then a raises to the second power because it decreases, whereas b increases to the first power. Plus, now I have 3 as my coefficient again. So 3a to the first power because we continue to decrease our a, and our b raises to the second. And then last but not least, I should have 1 as my coefficient again. And a is now to the 0 power, so that's going to go away. And now my b is to the third. So I stop when my exponent hits that n value. So if we do this one more time, go ahead and pause here and see if you guys can write out what the fourth, what a plus b to the fourth will look like. So go ahead and take a look and make sure you've matched as well. So we have this pattern where our first term starts with the nth power and then decreases till it hits 0. And then our second term starts with 0 and increases until it hits n. Also, notice how many terms we have. If we have an n value of 1, we have 2 terms. N value of 2, we have 3 terms. N value of 3, we have 4 terms in our expansion. N value of 4, we have 5 terms in our expansion. So we always wind up with n plus 1 as the number of terms, one more than what our degree is. In 7b and in our discussion on 7a, we also realize that this Pascal's triangle, the binomial coefficients, are winding up coming from a combination. So this 1 really comes from 0 choosing 0, and then here we have 1 choosing 0, and 1 choosing 1, and so on and so forth. So we're looking at this n choose r as our binomial coefficient. So if we were to expand a plus b to the nth power, we would start off with n choose 0. We'd have our term a raised to the nth power, and b would be to the 0 power. And this would wind up continuing until we wind up with n choose n. Then we have our a is to the 0 power, and our b is to the nth power. So if we just take a look at what this expansion really looks like, and we hone in on one term, we always really have this n choose r, this value, We always have one more than what our R value actually is. Our binomial coefficient is always n choosing R, and our A term is always to the n minus R, and our B term winds up being to the R. So if we add all of these terms together, we wind up with a summation of each of these terms. So let's take a look at what this actually looks like when we apply it to a real question with real values. So given the example, x squared minus 3 over x, and everything's raised to the 6th power. What we first have to make sure we realize is that our A value is really going to be this x squared term, and our B value is going to include the negative. So it is going to be negative 3 divided by x. So when we're using this formula, we make sure that we identify what our A value is and what our B value is. Then we can start with our expansion. So our very first term is going to be n choosing R. So our n is 6, and the first binomial coefficient is going to be when we choose 0. So this is satisfied. Our A, which is x squared, we're going to use brackets to write that out. And we are raising that to the n minus R. So 6 minus 0 is what we're really doing here. And I'll write this out for the first time. Our next term is B. So we've got negative 3 divided by x. And we're raising that to whatever the position is that we're on at the moment. So 0 is our R value. Again, this goes back to our A value always starts with n. Our B value always starts at 0. And now we'll progressively follow the pattern as we go. So with our next term, we'll have 6 choose 1. And our A value of x squared is now going to wind up being 6 minus 1. So we're going to drop to 5. So we dropped from 6 down to 5. Whereas negative 3 divided by x is going to go up. So again, this is always to the R. So 1. All right, go ahead and continue. Pause here and see if you can continue to writing this out all the way through 6. So n equals 6. All right, so at this point, just double check that you've agreed and that you've been able to expand it. We'll never wind up asking you guys to expand further than something that's reasonable. So even 6 is actually still reasonable to write out by hand. However, most questions will ask you maybe for the first few terms and the last few terms, or the last few for the coefficient. So we'll go through some of those examples together. But this one, not so bad to expand it. However, we never want to leave it like this. If we can simplify, always try to simplify. So here's where we actually will find a number for x choose 0. We'll find a number for this negative 3 raised to a power. And then the x's, so x squared multiplied by negative 3 over x is really the same as x squared divided by x. And then that negative 3 becomes part of the coefficient. So let's go ahead and try to simplify this. Just looking at the first term, 6 choose 0, we know is going to be 1. X squared raised to the 6th power will wind up being x to the 12th. And then we have negative 3 over x raised to the 0 power. Again, that's just 1. So we have 1 x to the 12th power. So let's take a look at the next one then. 6 choosing 1, so we'll wind up with 6. X squared to the 5th power will wind up with x to the 10th. And then negative 3 divided by x raised to the 1st power, we're going to wind up letting the negative 3 multiply by the 6. So already, let's go ahead and clean this up a bit. I've got x to the 12th. This is going to wind up being negative 18. And then x to the 10th divided by x will wind up being x to the 9th. All right. So now when we get to the next term, 6 choose 2. If we start to get to values where we're not sure what the binomial coefficient is, we can always come to our calculator and we wind up going to calculate. And here's our menu. We'll go to probability, which is where our combinations is. And we are going to put in 6, choose, so comma, and 2, and enter, and we get 15. So if we start getting to a binomial coefficient that we're not sure, we can't think of it in our heads, go ahead and find the coefficient using your calculator. And then you guys can reduce. So go ahead and pause it here and try to simplify this expression. Okay. All right, so once we've simplified down, again, remember since n is 6, we should have 7 terms. So we've got this first 2, 3, 4, 5, 6, 7. And these last two terms, so we always want to write with a positive index. So this is x cubed. This is the same, obviously, as negative 1,458 x raised to the negative 3. However, we want to write with positive indices as much as we can. And then, so other questions that might come up, they might say to write the first two terms and the last two terms. So then we could just put plus dot, 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 plus, and then we can skip to the last two terms. We might be asked to find the constant term. So the constant term would be the one term that does not have any pronumeral. So 1,215 would be our constant term. Or it might ask you to find the term with x to the 6 in it. And so we'd have to find that one term. So while this is great and we're stringing together the entire expansion, we can also just focus in on one specific term. So our next example will be looking at that. All right, guys, so second example is find the 7th term in this expansion. And I'm just going back, again, here's our term formula. So I'm just copying it again so we have it right in front of us. And what we really want to find is the 7th term. However, the 7th term would mean that we're really finding r as 6 plus 1. So if that's the case, then we choose n as 9 in this question, and our r value will be 6, because it's always 1 less than, since we have one more term, n plus 1 terms. Our a value is 2x, and we're raising that to the n minus r, so that'll be 9 minus 6. And our b value is 5, and we're raising that to the 6th power. So I'm just taking each of the values that I'm given, identifying this as a, identify this as b, this is our n, and if we want the 7th term, we're going to use r as 6, okay? So once we simplify, find 9 combination 6, or 9 choose 6, go ahead and raise 2x to the 3rd power, and then 5 to the 6th. Pause here, try this one, and see if we match. All right, so we end up with a very large number, but again, we can actually multiply that out and simplify it down, okay? So 9 choose 6, we've shown you how to use with the calculator. Also, remember that from last lesson, 9 choosing 6 would be 9 factorial divided by, and then we've got 6 factorial times 3 factorial, n minus r factorial. So again, that value is corresponding to what you guys are getting in your calculator as 84 on this example. Multiply all your coefficients, and you get your actual coefficient of the 7th term, all right? We will do more examples like this in class using both of these formulas, but you want to be familiar with how to expand and then also how to identify one term if a question specifically asks you for that one term. All right, see you guys later.